Hi, welcome back to the bunker. Today we are going to take a quick overview on air pollution and air pollution issues. Kind of give you a quick overview on what air pollution and smog are. We're going to start talking about something that affects Asia every year called the Asian brown cloud. And it has to do with the amount of industry, the amount of pollution that there is in Southeast Asia. Kind of showing that air pollution isn't just a local problem. For years, it was looked at as a local problem, and that you could take measures at the local level and do local solutions and not have any issues down the line. But what the Asian brown cloud shows is that that is not the case. So in 2002, there were some satellite images taken over Southeast Asia that showed this huge, literal brown cloud that actually stretched from India through China and way out into the ocean. Ground level wise, it's about 2 miles thick. It's about the size of the US, so this is not a small area of pollution. And about a third of it is just dust and smoke and ash, small particles that comes from the burning of forests that is occurring and trying to clear land for farms and for crops and things like that. Everything else that's there is all acidic compounds, soot, mercury, lead, things that are just not overall good for anybody to be exposed to. And most of that comes from the industry that's there, burning fossil fuels, transportation, those types of things. Because there's this cloud here, it reduces the amount of photosynthesis that is happening. And they're finding that those particles that are in there do act like greenhouse gases. So it is increasing the temperature of those areas, which contributes to global warming. And they also have serious health impacts on the people who live there. Remember, that part of the world has close to half of the world's population. And they are all being exposed to this nasty cloud of pollution and particles and just gross stuff that happens to be floating in there, and they're breathing that in on a daily basis. So it does increase the mortality rate in that area. Now, what they found with these satellite images is that it stretches across the ocean, and they're finding that about a quarter of the particulates and about a third of the mercury that they actually find in Los Angeles come from this Asian brown cloud. So it is able to transport itself over the Pacific Ocean and cause pollution problems in LA, which is crazy to think about because the Pacific Ocean is not small. Watch a quick CNN report on this here.
All that car exhaust and pollution from power plants and factories, all that smoke, soot and ash from cooking food and burning crops, it all has to go somewhere. And that somewhere is here. From the ground looking up, it's the heavy blanket of smog which seems to be an almost permanent fixture of many Asian cities. From satellite photos looking down, it can be seen stretching across India, China and beyond. Scientists call it an atmospheric brown cloud, a toxic cocktail 2 miles deep, covering tens of millions of square miles from the Arabian Peninsula to the Western Pacific and growing.
The atmospheric brown cloud is both complex and in need of a great deal more attention.
Scientists first raised the alarm 6 years ago. Now they say they know much more about the cloud's impact on climate change. Because the cloud absorbs the sun's rays or reflects them back, ground temperatures are cooler, masking the impact of global warming, while temperatures in the upper atmosphere are higher, explaining why Himalayan glaciers are melting much faster than expected. And scientists say every year the cloud is reducing the amount of sunlight reaching New Delhi, Karachi, Shanghai and Beijing, 25% less since the 1950s. And that's changing rainfall patterns across the region.
Because sunlight reaching the ground evaporates moisture, and this moisture goes up in the air and then falls down as rain. So when you cut down sunlight at the ground, you will cut rainfall.
The UN report estimates the changing weather pattern costs $5 billion annually in crop losses, while exposure to the cloud's particulate matter kills more than 300,000 people every year in China and India. If we stop producing all of the emissions which make up the cloud, scientists say it could disappear in just 2 weeks. But as unlikely as that is, they warn if it did happen, global temperatures could rise by 1, perhaps 1.5 degrees Celsius. John Vors, CNN Beijing.
Okay, so what exactly is air pollution? Pollution is any sort of chemical or anything like that that when in an environment causes an undesired change in that environment. In this case, we're looking at things that are in the atmosphere. So it would be the presence of chemicals in the atmosphere that are in concentrations high enough to actually harm organisms or harm ecosystems. They come both naturally and anthropogenically from, which would be man-made sources. Naturally, they're dust that's blown by the wind. When there's wildfires, any sort of fire produces a lot of soot and smoke that will go up in the air and essentially acts as air pollution. As well as some plants release chemicals that actually inhibit the growth of other plants around them. These are pollutants that the Earth is equipped to deal with. Volcanoes erupt all the time. Volcanoes erupt for billions of years. The Earth has been able to deal with these types of things, and it has its own cleaning mechanism in the atmosphere called the hydroxyl radical that helps react with these pollutants and remove them from the atmosphere. It's where we go beyond that with our anthropogenic sources that becomes a problem. These are generally locally emitted things, mostly in industrial or urban areas, and for the most part come from the burning of fossil fuels. Most of our particulates and those types of air pollutants, as well as sulfur oxides, nitrogen oxides, get released by burning fossil fuels. And so that is a major source of the anthropogenic air pollution that we see. We classify these air pollutants in two different ways. There are primary pollutants and there are secondary pollutants. Primary pollutants are things that are the actual emitted pollutant that are directly emitted, right? Carbon monoxide, lead, nitrogen oxides, and sulfur oxides, the stuff that actually comes out of like the smokestacks and the exhaust pipes, or blown up from the ground if it was dust. All right, those are primary pollutants. Secondary pollutants have been changed. You take a primary pollutant and like sulfur dioxide and you add it to water, and it's not sulfur dioxide anymore, it's now sulfuric acid, or becomes acid rain. You take some volatile organic compounds, which is what VOCs stand for, and we'll look more at that in a second, and you add some sunlight to it and you get smog. All right, those are secondary air pollutants. So primary, once again, means that this is what is directly emitted. So they are the directly emitted pollutants. All right, like I said, like lead, carbon monoxide, particulates, VOCs. And these are the types of things that you can actually regulate. By regulating the primary air pollutants, it's easier to limit the secondary air pollutants that can mix with something else and become sometimes even more harmful, like acid rain or smog.
Air pollution consists of chemicals or particles in the atmosphere that pose serious health and environmental threats. But what causes air pollution, and what does it mean for our planet? Some air pollution comes from natural sources like volcanic eruptions, wildfires, or allergens. But most air pollution results from human activities, such as energy use and agriculture. There are different types of human-made air pollution. When we burn fossil fuels to produce energy, they release greenhouse gases into the air. These emissions, such as carbon dioxide, methane, nitrous oxide, and fluorinated gases, trap heat from the sun in Earth's atmosphere, leading to a rise in global temperatures. This creates a cycle where air pollution contributes to climate change, and climate change creates higher temperatures. In turn, higher temperatures intensify some types of air pollution. For example, climate change increases smog because it forms in the presence of high heat and increased levels of ultraviolet radiation. More frequent extreme weather, such as flooding, contributes to damp conditions and therefore to a rise in mold. Warmer weather also leads to longer pollen seasons and therefore more pollen production. Smog is a type of air pollution that reduces visibility and has serious health effects. Smog can be divided into two categories: sulfurous and photochemical. Sulfurous smog is made up of chemical compounds called sulfur oxides. It occurs when burning sulfur-bearing fossil fuels such as coal. Photochemical smog, also called ground-level ozone, is a result of the reaction between sunlight, nitrogen oxides, and volatile organic compounds. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. Volatile organic compounds are released from gasoline, paints, and many cleaning solvents. Smog not only creates a brown haze that reduces visibility, but also harms plants, irritates the eyes, and causes respiratory distress. Another category of air pollution is toxic pollutants. These are chemicals such as mercury, lead, dioxins, and benzene that are released during gas or coal combustion, waste incineration, or burning of gasoline. In addition to adverse environmental effects, toxic air pollution can cause serious health problems such as cancer, reproductive complications, and birth defects. While air pollution has many consequences for our planet, there are solutions. We can limit toxic pollutants, smog, and greenhouse gases by decreasing the use of fossil fuels, such as in transportation, manufacturing, and electricity generation. Reducing air pollution not only contributes to a cleaner environment and better human health, but can also slow the rate of global warming.
Okay, there are 7 major outdoor air pollutants that are regulated by the federal government under the Clean Air Act that set up National Ambient Air Quality Standards, or NAAQS is. And these 7 things are the 7 major pollutants that are outside that the EPA tries to regulate the most. So we'll start with particulates. Particulates are just particles. They are suspended in the air. Right? It's like when you see like a haze or smoke or dust, these are actually all teeny tiny little particles that are up in the air. For the most part, they come from natural sources, dust, wildfires. However, an extensive use of fossil fuels or even tobacco smoke can increase the amount of particulates that happen to be in the air. There are several different forms of particulates. The most harmful ones are they call them PM 2.5. That refers to the size of the particles. These are very small particles. These get in past your respiratory systems, defense systems, and can get into your lungs and irritate them or damage them. They can make asthma worse, if not trigger asthma attacks, or COPD, which is a chronic bronchitis, and overall reduce life expectancy. Generally, particulates are in higher levels in more urban type settings, urban, suburban, those types of things. And some of the more toxic particles will cause cancer or brain damage and birth defects. Volatile organic compounds are organic compounds, and when they're volatile, that means they're going to react pretty easily. All right, for the most part, they're hydrocarbons that are going to come from burning of fossil fuels and even just through the evaporation of hydrocarbons, like evaporation off of gasoline or even off of paint. Mostly they are from human sources, oil and natural gas wells, cows, right? That's the methane part of it. There are other VOCs like benzene, which is actually found in cigarette smoke, as well as like diesel exhaust and truck exhaust, and as well as vinyl chloride. These are things that are used in cleaners and paints. Paints nowadays are required to be VOC free, and when you look in the can, they they talk about that, because what happens with paint is it's wet, obviously, when you put it on the wall, and as the water evaporates, it leaves behind the paint color on the wall. But as the water evaporates, there are chemicals inside of there, and you can smell those things as that evaporates off the wall. And inside of that were VOCs that people were being exposed to. And so when you're painting like a new baby's room, you don't want the baby to be exposed to those VOCs. So you want to find VOC-free paints. When we talk about carbon oxides, we mainly focus on carbon monoxide. Carbon monoxide says color odorless gas that blocks the delivery of oxygen to organs by not allowing hemoglobin in blood to bond with the oxygen. All right, your hemoglobin is designed to bond with oxygen so that when you breathe in, oxygen diffuses from your lungs into your blood, bonds to the hemoglobin in your bloodstream, in the red blood cells, and then gets carried to different parts of your body. Well, hemoglobin actually bonds faster to carbon monoxide. So if you're being exposed to carbon monoxide, you're going to be taking in less oxygen into your bloodstream and more carbon monoxide, and almost essentially suffocating in that. Because it's colorless and odorless, you don't know you're being exposed to it. You start to feel tired, maybe take a nap, but it's a nap that you don't really wake up from. It is very important that you have a carbon monoxide detector in your house. Once again, being colorless, being odorless, you don't know it's there, but they make specialized detectors that will warn you if the carbon monoxide levels are too high. If something has gone wrong with like your furnace, when it says sources include car exhaust and furnaces and tobacco smoke. All right, if there's something wrong with your furnace and it starts leaking that carbon monoxide, right, it can trigger asthma, it can trigger heart attacks, it can just make you sleepy and you don't wake up. So having an alarm that tells you to get out of the house is important with that. All right. We also have sulfur dioxide and sulfuric acid. Sulfur dioxide would be the primary air pollutant, would be the sulfur dioxide. Sulfuric acid would be the secondary air pollutant. It's what gives it a rotten egg smell. It mainly comes from burning fossil fuels, especially coal. Coal has a pretty high sulfur content. And so when you set that on fire, you combine that sulfur with oxygen, you get sulfur dioxide. When that sulfur dioxide mixes with water in the atmosphere, it forms sulfuric acid, which lowers the pH of rainfall and gives you acid rain. It is mainly from fossil fuels, especially coal. So this would be a lot of our electrical power plants. Nitrogen oxides come from combustion, as well as fertilizers as well. We know there's nitrogen in fertilizers, but probably the main source would be burning fossil fuels in our cars. The way combustion is supposed to work is you take a carbon compound and you add oxygen to it. Our atmosphere, though, is 78% nitrogen. And so when we pull air into our engines for combustion, for our internal combustion engine, we're not just combusting oxygen, we're also getting nitrogen in there as well and creating these nitrogen oxides. All right, the nitrogen oxide would be the primary pollutant form of that, and it can mix with water to form nitric acid, which would be our secondary pollutant with that in there. All right, ozone. We know ozone is good. Ozone belongs in the stratosphere. It helps protect us from incoming UV radiation, especially UVB radiation. However, ozone can also form in the troposphere. When it's in the troposphere, that's when we think of it as bad ozone. All right. Generally, we refer to bad ozone as smog. All right. Smog and bad ozone have a very similar chemical structure to it and similar chemical formula, so they're kind of the same thing. So tropospheric ozone would be bad. When you're exposed to that, you get like a burning in your lungs. It can burn your eyes. As you saw in the video, a lot of the people were wearing the medical masks that unfortunately we're becoming used to seeing around, because it helps reduce those particles that you're breathing in with that. But not only does bad ozone affect humans, but it damages plants. It damages their tissues and makes it harder for them to complete photosynthesis. And it has a negative impact on fabrics and paint and the rubber in your tires. It can lead to an early breakdown of that as well. All right, when we look at sources of air pollutants, this is where you're going to find the majority of where they're going to be coming from. The particulates are the dust and those small particles, so like dirt roads, construction sites, agriculture, any of those places are going to spread a lot of those particles. If you look at a lot of these, though, carbon monoxide, sulfur dioxide, nitrogen oxides, a lot of what releases this, especially like with lead and even VOCs, are transportation or electrical utilities and power plants. These are all ways that we are burning fossil fuels. And so fossil fuels become a major source of the pollution that we see. So let's take a look at smog. Smog, pretty simple name. Somebody was like, that fog looks smoky. Called it smog. So it's a smoky fog. Scientifically, it's referred to as tropospheric ozone. Also, it can be referred to as ground level ozone. It's a very similar chemical compound, it's a very similar chemical formula. So they can use that same name like that. Generally, when you're exposed to it, it can increase the instances of you having headaches, feeling nauseous, your eyes and throat kind of feeling burning or itchy. If you have asthma, and really any sort of air pollution is going to be aggravated, it's going to aggravate any asthma issues that you have. And they have found in general that areas where there are higher levels of air pollution have higher rates of asthma. There have been times in the past as well, in Pennsylvania and England, where there have been sudden excessive smog events, when we say can reach lethal levels, that have actually killed people that have pre-existing conditions that would be affected by that. So if you have an excess amount of ground level ozone, it can cause death, especially in those people who have respiratory issues already. There are two main types of smog. There's industrial smog and there's photochemical smog. Right? Our industrial smog, it says it's generally sulfur compounds and water vapor, right? As well as soot. Soot would be the burnt up like coal that is flying through the air. So soot would be a particle. For the most part, industrial smog is grayish in color. And in mostly urban industrial types of areas. Here in the Detroit area, when you drive down I-75 and you get by the Ford River Rouge plant, there's a ton of industry there. There's a very tall bridge that goes by there, and there lots of times the sky has a gray haze to it right around there, and that's industrial smog that you're seeing in that area as you drive through there. With photochemical smog, the thing that makes it photochemical is the photo part. Right? Photo is sunlight. So it says it's a mixture of primary and secondary pollutants under the influence of UV radiation. All right, so that's the big key with photochemical smog, is that UV radiation. All right, UV radiation reacts with these primary air pollutants and like VOCs, for example, and converts it into this smog, into this ground level ozone. Generally, photochemical smog looks brownish, and it's everywhere. It is in all modern cities, especially where there's a higher level of traffic, more cars driving around. It is more pronounced in areas that are warm and dry with lots of cars, especially like Los Angeles. Los Angeles is usually the city you hear about a lot when it comes to smog, and it has to do with Los Angeles's topography, with the landforms that are there in the landscape, as well as their population and the amount of the population that drives. So this is just showing you a difference between the two different types of smog, right? Your industrial smog being over here on the left, and your photochemical smog being over here on the right. Right? So I mentioned with Los Angeles having higher rates of smog, and it has to do with their landscape. That leads to that. There are certain areas where, like Los Angeles, where the weather conditions can actually increase the severity of air pollution. What should normally happen is you should have the sun. The sun, when it comes up, the sun's rays come through, they warm the ground, they warm the air at the ground. The air at the ground then rises. And when it rises, it carries those pollutants with it. In areas, though, where they have temperature inversions, right, something happens where rather than the ground level layer becoming warmed up, it's a mid-level layer that gets warmed up, and that acts like a lid on top of the colder air that's at the ground. So rather than the warm air rising and bringing the pollutants with it, like it's happening in the normal situation, that cold air just sits at the bottom and collects those pollutants in there, which then, when exposed to sunlight, are going to rapidly convert into smog. With Los Angeles, what happens is they have a mountain range off to their east. They're bordered on one side by the ocean, the other side by a mountain range. That mountain range blocks the early morning sun as the sun comes up. And so the sun's rays warm this mid-level layer of air, keeping the ground level cool, which traps in those pollutants. And then as the sun continues to rise, you have a higher level of these pollutants, these primary pollutants that could lead to smog, and that are trapped near the bottom. And once the sun does come up, you're going to have a rapid conversion over to that secondary pollutant that becomes smog. That is called a temperature inversion because you flipped the warm air and the cool air in the order of the layers where they should be. So indoor air pollution is probably an issue we should probably be more concerned about. Outdoor air pollution is bad, and we can regulate outdoor air pollution fairly easily because you can regulate it at a source. Indoor air pollution, though, affects all of us, rich, poor, wherever you are. However, the World Health Organization does say that indoor air pollution is, like for poor people, the world's most serious air pollution problem, because in lesser developed countries, there is a lot of burning of fuels that happen inside in open fires in unvented homes. So it just collects the soot and those smells, and those air pollutants build up in the home, and they don't get vented out to the outside. For those of us in more developed countries, we're not off the hook, though. All right, and this is the big thing: indoor air pollution is a much greater threat to human health than outdoor air pollution. And the reason for that, well, if you think about it, when you are in the outside, the air that you're breathing is air that is being mixed with air all over the world. Right? It is the entire atmosphere. It's your quote-unquote home, your system that you're in. All right? There's much more air to mix in that. When you are inside, though, right, that air is being recycled throughout your home. Right? And those pollutants stay trapped inside. Right? When you're in your home, think about, like, if you're in an airplane. Right? People think about being in an airplane like if one person is sick in the airplane, then everybody else in the airplane gets sick. All right? Think of that the same thing as being in your house. You're recycling that air. Whereas globally, you're diluting that air a lot more because there's just a lot more of it. So being inside, in the U.S., it says the 11 common levels of 11 common pollutants are 3 to 5 times higher than outside, right? Because they get trapped inside, they build up inside over time. If you're stuck in traffic, the pollution levels are very high. Your car sucks in air from the outside to bring inside and cool you down and get air moving inside of your car. Well, that's going to trap those pollutants inside of that. Right? And then, still in the U.S., we're magnifying these risks because most of us just spend all of our time inside. Right? 70 to 98% of your time is spent inside. Getting outside reduces the effects of these indoor air pollutants because you're outside. But there is a phenomenon we see in the U.S. called sick building syndrome. All right, people who spend a lot of time in a specific building do report more acute health effects that are related to time inside of that building. Headaches, dizziness, sneezing, sore throat, irritability, chronic fatigue, flu-like symptoms, depression. Just think of what it's like being in that school building. That school building has been around for a long time. There are a lot of things up in that ceiling that can get knocked out and loosened up. And the more time you spend inside of a building, the more you are exposed to those pollutants that are inside of there, and the more you see those effects. of the, like, if you have allergies, especially, like a lot of the times being inside a school building, for me, it seems to set off my allergies, having dust allergies, and things like that. But being able to get outside, I'm able to avoid that. But when we say the sick building syndrome, it's referring to the building that you're in is sick, essentially, is causing a sickness. This figure is showing just important indoor air pollutants that we see and where we find them. If you smoke inside or you have a fire inside, it releases a lot of pollutants. There's a lot of sources of particulates that are inside of there, as well as things like asbestos, which we know is dangerous, but it is still inside, like insulation and other things in our house as well. We're going to talk more about some of the major indoor air pollutants, but they are kind of shown sources on here like chloroform and formaldehyde. All right, asbestos, especially carbon monoxide. All right, and radon. We'll talk more about radon. So if we think of 4 indoor air pollutants, like public health officials say there are 4 indoor air pollutants that are the most dangerous to people in developed countries. All right, if we start with tobacco smoke. Tobacco smoke is the world's most preventable major cause of suffering and premature death among adults. When we say preventable, it's because smoking is a choice. No one is being forced to smoke cigarettes. It is a choice that you make. In the U.S., 1 person dies every minute from some sort of illness that is related to their tobacco use, to their cigarette smoke use. All right, they have tested cigarette smoke, the smoke that's coming out of your cigarettes, and they have found benzene, acetone, ammonia, formaldehyde, lead, almost 600 other compounds, 69 of which have been shown to cause cancer. All right, secondhand smoke, we know the dangers of just 1 person smoking. There are plenty of advertisements talking about the hazards of smoking cigarettes, but there are also hazards that come along with secondhand smoke. All right, and they're finding that secondhand smoke is also a known human carcinogen because of what happens to be in that smoke. And if you are exposed to secondhand smoke, they actually consider that passive smoking because you may not be smoking the cigarette, but you're still taking in that smoke. And in a lot of cases, it's the people being exposed to those things don't have a choice. All right, like kids. And there are different states that have passed laws basically making it illegal for you to smoke in the car with kids. That's one of those things that's very hard to enforce, but they're trying to let people know that, this is something that is harmful to children. Radon is something that when you get a house, you need to test for. Right? Radon 222 says a colorless, odorless, radioactive gas that is completely natural. It occurs natural from the breakdown of uranium that happens to be in the rock. Right? When you're outside, it just goes in the air. It's not a big deal. But when you're inside, it can build up inside your home. It gets in through cracks in the foundation. It gets in through openings, especially mainly in the basement. When you're looking at sump pumps, hollow concrete blocks. We have drains in our basement that help drain water out to the sewer system, but that allows radon to get in through it as well. Radon, after tobacco smoke, is one of the leading causes of lung cancer in the U.S. And so having your home tested for radon is super important. All right, I've had 2 houses in my life. In both times when we bought that house, we had to get a radon test done. The house that I currently have had a slightly higher elevated level of radon, and because of that, we had to get a radon mitigation system. And what they do with that is they seal off as many areas, possible entry points for radon as possible. And then in your sump pump, they seal off the hole where your sump pump is, and they stick a pipe down in there with an exhaust fan that pulls as much air out of that sump pump as possible, and then vents it out near the roof of your house and vents it in the atmosphere where it disperses harmlessly in there. But if you buy a home, that is something you definitely need to make sure you have checked out. Formaldehyde is actually a preservative. Right? If you go to a biology classroom, there may be some specimens in a jar in some sort of fluid. That fluid is usually formaldehyde. Formaldehyde mainly affects people in developing countries, or sorry, developed countries where you have more exposure. It can lead to dizziness and headaches and rash and sore throat and just kind of overall and irritating. But it isn't our everyday household items. If you have pressure treated wood, right, that is part of the chemical concoction they're using to treat that wood to make sure that it doesn't decay, which is an important process. Formaldehyde is in that to help reduce the decay rates of the wood that you have, which allows your deck or other things that are outside that are exposed to water to be able to withstand being exposed to that water and not decay. But they also put it like in furniture, in your drape, in your carpets, in any sort of upholstery that might be on your couch. It's in wallpaper glue. It's part of what makes your wrinkle-free pants wrinkle-free. So it is everywhere. Finally, asbestos is, as you can see in this picture, is like a fiber-like crystal. It says it's a silicate mineral. So it's basically these crushed up minerals. It's used for fireproofing. It doesn't tend to catch on fire very easily. It also absorbs sound pretty well and is a very good insulator. And it's been being used for a couple thousand years now. What they're finding, though, is that breathing in these tiny particles tends to cut up and scar up your lungs, which reduces your lungs' ability to take in the oxygen that it needs, and can then also lead to lung cancer, can lead to mesothelioma as well, as these tiny crystals cut up and scar your lung tissue. About 30-40 years ago, there was a huge lawsuit in the US that exposed how bad asbestos was, and they started to realize the amount of asbestos that was in buildings, especially in school buildings. In school buildings where they had those ceiling tiles, if somebody slammed the door hard enough, it would snow, and it would be like snowing these asbestos crystals, and kids were breathing in it all the time. No one, at least the public, wasn't aware of these dangers until somebody did some research and noticed the rates of lung ailments that were occurring and was able to tie it to asbestos. And since then, there's been a pretty large ban on the use of asbestos in certain products. So how does air pollution affect us? We breathe in about 30 pounds of air every day. Our respiratory system is designed to deal with things that we would normally come in contact with. Right? We have hairs in our nose that kind of stop and they act like a net and collect big particles that go in our nose when we breathe in. And then those things get collected and basically become boogers that can get swept back down our throat and into our stomach where they get destroyed. We also have very sticky mucus inside of there that then catch smaller stuff. So there's several lines of defense as you breathe in. When that system is overwhelmed, you cough or you sneeze to get rid of any sort of contaminants. When the system gets irritated, when the system gets overwhelmed and is trying to get rid of stuff as fast as possible. However, there are certain pollutants out there that when we are exposed to over long periods of time, increase our risk of lung cancer, asthma, emphysema, and other respiratory illnesses that occur. I'll highlight that one up there too, because that's you don't think about air having a weight to it, but it does have a mass, it does have a weight, and 30 pounds is it's basically a toddler's worth of air every day. According to the World Health Organization, about 3 million people die every year from air pollution related causes, right, of being exposed to these indoor air pollutants, these outdoor air pollutants at higher levels. And so 20% of the world, 1 in 5 people, live in areas with unhealthy air. All right, a lot of that has to do with urbanization and living near these industries and near large concentrations of cars and things that are burning fossil fuels. But in general, the people that are affected the most are older people, are babies, are pregnant women, or people who already have respiratory diseases. So this image is just showing some effects of air pollutants. The respiratory effects seem normal, but there can also be cardiovascular effects. Your cardiovascular system is your heart working along with your lungs to move oxygen through your body. And exposure to air pollution can increase cardiovascular stress and lead to chest pain and heart disease and those types of things. So back in 1970, the Congress passed a law called the Clean Air Act. The Clean Air Act required the EPA to set National Ambient Air Quality Standards, or NAAQSs. All right, and this is for 6 outdoor air pollutants. All right, carbon monoxide, nitrogen oxide, sulfur dioxide, suspended particulate matter, ozone, and lead. With the suspended particulate matter, they're looking at, there's 2 sizes of particle, 2.5 and 5 with that. So sometimes they will say there's 7 NAAQSs because of the 2 different types of particulate matter. The good news is that since the passing of the Clean Air Act, we have decreased the concentration of pollution by about 46%. Even though there are more people driving, we have a much higher population now. So that's good. And the Clean Air Act has been reauthorized several times. Bad news is that with that increase in population and driving, more Americans, says 1 to 3 Americans, live in an area where air is unhealthy to breathe for part of the year. These are areas where there are higher levels of ozone and higher levels of particulates, areas where we're exceeding the National Ambient Air Quality Standards for 1 or more of the NAAQSs. The issue with this becomes the EPA was a politically created agency, and it is subject to changing political views and changing political times, and they act at the behest of the current presidential administration. And so every time we have a new administration, something gets changed with how the EPA is run and what they focus on, and how standards, what sort of standards there are, and whether or not there are more standards or less regulations or things like that. And in a lot of cases, the EPA is not well funded, and so our standards are generally not necessarily well enforced because they just don't necessarily have the manpower to track everything down. All right, this just gives you a quick overview of the Clean Air Act that's been around since 1970. They project that the Clean Air Act has prevented 160,000 deaths from respiratory and air pollution related causes, and that has saved us a lot of money as well. That's just $2 trillion saved by improving our air quality. So when we talk about, 1 in 3 Americans live in an area where part of the year their air does not have attainment or is not meeting the National Ambient Air Quality Standards. This map is kind of showing that sort of thing. Areas in yellow says that there are counties that are designated non-attainment. All right, if we talk about how air pollution is not necessarily a local issue, if you look at the map here where these yellow, Los Angeles would be right around here. And it's not just Los Angeles that has the non-attainment, but everywhere east of there as our winds blow from west to east. Here in the Detroit area where we live, we generally have a non-attainment for 2 National Ambient Air Quality Standards, generally the ozone and the particulates. But that does vary. Weather does affect that as well. So what can we do about this? How can we reduce outdoor air pollution? Well, there are accepted methods for removing particulates from exhaust pipes. There's a thing called an electrostatic precipitator. Imagine rubbing a balloon against your head and sticking it to the wall. All right, they're using static electricity to pull particles out of the air that is coming out of these smokestacks. And there are things like wet scrubbers that do the same thing. And these are all things that are focused on using particulates or getting particulates out of the air that's being released. Probably the number one thing to do to reduce outdoor air pollution would be, it says use less polluting fuels. The biggest thing is use less fossil fuels. When we say use less polluting fuels, reducing our reliance on fossil fuels is going to reduce air pollution and outdoor air pollution, and reduce particulates. It's going to reduce sulfurs and nitrogen oxides, all those types of things. And finding ways to reduce our fossil fuel use is important to leading to a reduction in outdoor air pollution. And that's where these other suggestions come in. Using mass transit like the subway or a bus, or carpooling, or even if you can walk or ride your bike, or improve fuel efficiency. Improving fuel efficiency means we're getting more miles per gallon of fuel that we're using. As far as indoor air pollution goes, this is something that you personally have a little more control of. Open a window. We say increase the intake of outside air. Open a window. If it's a nice day out, open a window. Let some outdoor air come in. The outdoor air is cleaner than the indoor air. Right? More and more states are starting to pass indoor smoking bans, where now restaurants used to have smoking sections and now they do not. And so banning smoking indoors doesn't just make it a better experience for you, but the people who work there as well, that don't have to be exposed to the secondhand smoke. Make sure that you take a look at radon in your home. Radon is that second leading cause of lung cancer. So taking a look at radon and preventing the infiltration of radon in your home, it would be huge for reducing indoor air pollution. And taking a look at where your indoor office machines are. All right, those giant copy machines actually release a lot of particulates as they go, and there's a lot of chemicals involved in that. And you want to use those in areas that are well ventilated. Use exhaust hoods for your stoves and your appliances that use natural gas. That's going to reduce the amount of incoming carbon monoxide. And just in general, get out of your house more. 70 to 98% of the time of their time Americans are spending inside. Get out more. It's going to reduce your exposure to those indoor air pollutants. All right, that's the end of our lecture. Thanks for stopping by. Hope you have a good day.